So for those of you who don't know me, I'm Andy Gill in real life, or Zephyr Fish on the internet. I specialise in offensive security, and I work for Larry's Consulting, who are now rebranding as the Mobile Security Services. I'm an insomniac, so most of my work is done between 11 p.m. and 6 in the morning-ish. In my free time, I enjoy taking a lot of photos, so I've got a blog that I upload photos to. I now own an Audi R8. I used to own a Focus RS. I used to fucking take pictures of it all the time. Shit, I just swore. We're all good. 60 seconds. I say I do karate. I've not actually trained in 2 years, but I do hold a black belt, so not only am I a keyboard warrior, I'll break your legs as well. So, co-host of the podcast, I have my other co-host here, Dave. We've got WouijaCast. We've had quite a lot of people in the industry on it over the last 2 and a bit years, 24 episodes. Hoping to keep it going. Should be quite good fun. So, quick recap. Honey POC, what actually is it? So, round about 2020, a vulnerability called SIGRED came out. Now, SIGRED was a vulnerability that affected Windows DNS, and it was a remote code execution vulnerability. And it was being hyped up as, this is the next, massive vulnerability, as these things do. It had a logo, it had all this stuff. And Checkpoint were the original company who were like, we found this vulnerability, we're going to release a blog post at 8 p.m. UK time, and everything was hunky-dory. But my colleagues and I got together and were like, how long will it be till an actual proof of concept comes out, till someone actually exploits this? And I was like, 2 minutes. Got on, wrote a quick bash script to make a curl request to Rick Astley's video, just to rickroll people, because everybody loves a troll. And I uploaded that to GitHub, and that started getting hits within seconds. It was getting a couple of hundred hits every second. And one of my good mates, John Carroll, was like, you're getting a lot of hits, maybe you want to look at some analytics of this. So he suggested I looked at Think's Canaries. So canarytokens.org is a service that allows you to create URLs and binaries and PDFs and all sorts of file types that when they're opened or run or clicked upon, they send a callback. So a bit like command and control, but it's more for analytics and early signs of detection for compromise. So I created a binary that had a canary token embedded, and when it was run, not only would it rickroll the person, it would also send me a callback to say that it had been run. In the callback, it would give me the IP address of where it come from, the target IP, because the way that I'd coded the binary is that so you give it a -T flag and then put it in the IP, and that was loaded into the binary and sent back into the user agent. So the user agent had the IP and some other pieces. Kind of malware, not really, but it was purely benign. And it was designed just to have a bit of fun. In terms of timeline of events, so this talk, I gave the first part of this talk at BSides London, so this timeline's representative of BSides London with the addition of Log4j. I'll talk about Log4j later on. I didn't release a honey POC for that. I released a legitimate POC, but people didn't listen. So, first, everyone okay? Somebody got a machine gun? Okay, cool. Cool. No doubt. You can present if you want, it's fine. So the first POC came out in July 2020, and then round about April there was multiple vulnerabilities that came out in Exchange and Pulse Secure and various other things. And because I'm a shite bag, I just decided to release fake POCs, and this POC is the same as the first time round. And once that got a little bit of traction, I think I was getting around about 1,000 to 2,000 hits a day, which is quite a lot. No, not a day, sorry, an hour. I was getting a lot every hour. I got loads of hits. Kevin Beaumont suggested that in round about May time, why don't you just automate this? Like every single CVE that comes out, release a POC, automate it, and it'll be great fun. And that's what I did. And I'll talk about it in a second. I released a project, but I haven't actually released the framework because it's actually pretty dangerous as to what it does, but I'll talk about it in a minute. That would automate it per POC. Then in December last year, Log4j, the greatest vulnerability of all time, came out. And I decided, being the nice person that I am, that I'd release genuine POCs, here's a URL and here's the string that you can go and do, but change the URL to whatever URL you want. And about 5,000 people didn't change the URL from the default URL. So me being me, I'd set it as a canary token, and I got a lot more information than I thought I was going to get, and as a result, kind of learnt a lot about kind of insider threats. What the URL had in it was kind of an environmental variable string. So I had $open bracket hostname close bracket .domain.com, which is Linux for command execution for hostname. So if that ran, it would send a DNS request back to my endpoint with the hostname of the system it run on. Now, what I didn't account for is the fact that in a lot of corporate environments, the hostname is not just like John's PC or Jane's PC. It's johnspc.companyname.org or .local or whatever. So as a result, I got quite a lot of internal hostnames, and I bit off a lot more than I could chew, to the point where I got some intelligence services. I say intelligence. If you're intelligent, you're running things on the internet with no repercussions. You're not very intelligent, but hey. I got a lot of like SCADA companies, because there was a lot of vulnerabilities, and I'll talk about them later on the slide. And I got a lot of just interesting companies that I would have thought would know better. A lot of security consultancies in the UK running things. Not a good idea. So in terms of the data, so this is the data from the first POC, which is the SIGRED one. And for those of you who can't see the back, and the numbers are tiny, essentially quite a lot of the hits here are from like ASNs and from like cloud providers. So like you've got Google up here, China, everyone loves China. China again, AWS, Cloudflare. So most of it is like ISPs and hosting. Businesses were like corporate-owned IP ranges, and then like kind of the geographic spread. So the US was at the top, mostly because the vulnerability came out of US time. So a lot of the people that were going to execute things were in the working time zone. China, Germany, very small percentage. Hong Kong, Belgium. In the top 10, Russia and Ukraine were in there, but that's a bit of a touchy subject at the moment, so I'm not going to talk about it. All I'm going to say is before it... No, I won't. So, AutoPoC, what is it? Essentially, it's an automated creation of POCs, proofs of concept. It was designed initially to poll every couple of days, because CVEs get released all the time. You hear about the CVSS 10, so that the criticals, like, rare, they're like once in a blue moon, or they come about now and again. But I kind of... Originally, I designed it so that it would poll for a CVSS score of like 7 and above, so like high risk to critical risk. But then, because there were so many vulnerabilities coming out, I was like, you know what, I'll just do it from 0 to 10, because what's the worst that could happen? In a day, it generated 50,000 POCs, because I'd like put a semicolon in the wrong place, so I had to like fix that. And kind of because the first and second and third honey POCs were kind of trolls, this was just taking trolling to the next level. So how does it actually work? The script itself polls for CVEs from a database URL. So MITRE release CVEs, usually they are pre-reserved. So you can, if you find a vulnerability, you can report it to the vendor, responsibly disclosed, contact MITRE, request a CVE, and then you get like your CVE number. So you get like CVE 2022-1337. And that would be reserved for until the vendor patches the vulnerability. And what MITRE do is they list these on, so you can actually go into MITRE, and there's actually, they're all listed, so you can just be like, I'll select CVE 2020, 1520 or whatever, and that will eventually be a vulnerability in something. So I was pulling these all down, dropping them into a database, and then creating a Git repo for them, because this is where it gets a little bit questionable and sketchy, but fun. So I wasn't forcing people to run these things. I was putting them on GitHub, and people were downloading them themselves and running them and getting trolled. So yeah, create a Git repo, push the updates to the repo. So in the repo, it had a template for the file. So the template was a Windows binary, a Linux binary, and a README. And it had pre-populated text. So what it would do is it pull from the MITRE website the text. So if the CVE wasn't reserved, so if it didn't have reserved in it, it actually had details about the vulnerability, it pulled that blurb and put it in. So if you were searching GitHub for the vulnerability, it would give you the description and be like, oh, this looks legitimate. It's a random binary on GitHub. I'm sure it's fine. What it would do then is it would actually build from templates. So I'm going to actually talk about the source code a little bit more in depth, which I didn't talk about at London because I didn't really have enough time. So I was blasting data at people, and this is a bit more in depth. Once it built it, it would then drop the CVE and the Canary ID. So Canary, thanks Canary, kindly gave me access to their premium API, which enabled me to generate, I think it was like 100 million Canary URLs. I didn't use 100 million, but I had the ability to generate 100 million. And each of them was unique and embedded. So every time I got a notification, it'd be a unique URL, just for fun. And then kind of the stage after that was the kind of disinformation side. So my talk at BSides London was disinformation as a service. And the disinformation was automated uploads to GitHub, Pastebin, GoSpin, tweeting out from random Twitter accounts. So I worked out using Phantom.js to create Twitter accounts and GitHub accounts, which is kind of a bypass of bit of a break of the TOC, but it's fine. Once it done it all, it would then email me to tell me that the PLC had been created, and then it would kind of log each time it had been created. Each time it had been run. Every time it was run, it would then send me a Slack notification, because I set up a Slack channel, because everyone loves Slack, with a webhook, and I'll show you an example of that later on, as to what information it would give me. In terms of the templates, so you had Windows and Linux, because I wanted to cover the kind of two main. I mean, you have Mac OS, but it's quite hard to exploit Mac OS, and it's quite hard to automate stuff, because Apple are actually all right at security. They've got kind of walled garden approach, so you need to have permissions to do stuff, to do anything. If you want to access the terminal, you can click yes, blah, blah, blah. So Windows is much easier. Give somebody an exe, and they'll just run it. Apart from Smart Screen, which is are you sure you want to run this binary from the internet? And people use it just like this. And then the example we would just put the information in. The actual source code. So this is going to be quite difficult to read from the back, but I'm going to talk you through it. Essentially, this is the Windows template. So the first thing up here is the Canary URL. So this is a templated URL which pulls in. Then it looks on the host name. So when it runs on a Windows machine, it looks for the username, the domain name, the username, and the path. The path being environment and variables. Now this is what almost got me into trouble, because I was pulling in a lot of sensitive information. We'll get into that bit later. Then what it does is it pulls together the IP and things and concatenates them into a nice kind of block. Does that again, and then it puts it into base 32. Now I spoke about this in the first part of my talk. Base 32 is chosen because a lot of the time when people work in secure operations centers, they look at stuff, they go, that's base 32, and then decode it. But less often they see base 32, and base 32 is another encoding format, but a lot of proxies and a lot of corporate firewalls just allow it through. They're yeah, that's cool. So I use that to get data out. So arguably malware, but not really. The kind of sample the data. So I showed a lot of data at BSides London, and for this talk I didn't want to dive too much into it. So those of you who've seen the BSides London talk, there are rehashes of the data here, but in terms of the breakdown of execution, ideally I'd ask for the lights off, because blue on black is better to read in the dark, but essentially the 42% up there was threat intelligence companies, or as I like to call them, cyber espionage companies, because they just run shit and pass it to people. 20% up there was kind of opportunist hackers, so bug bounty hunters, people looking for I want to go and pop a Java server, I want to go and pop a water filtration plant or something. I just want to go and hack stuff. Kind of 10% down there was insider threats. So they were kind of what I classify as genuine insider threats, people inside of companies that are targeting systems not from a testing perspective, but looking to gain either financial motive or whatever else. And then the kind of 28% there are kind of random threats. Originally, when I gave the talk in November, I said, well, that wasn't sandbox traffic, but I went back through the data a couple of weeks ago. In actual fact, probably that's split about 20% of it is just random data from all over the place, and 8% is split sandboxes. So quite a lot of them got uploaded to VirusTotal, as you can imagine. Find random binary, put it in VirusTotal, put it in Joe's Sandbox, put it in all the other sandbox sites. So I got quite a lot of traffic. But interestingly enough, by having them uploaded to those sites, I was able to profile when I was getting traffic from sandboxes. So, because I work Red Team as my day job, I took all of the IPs and all of the indicators of compromise from a VirusTotal machine and built a blacklist or a deny list for command and control. So every time we go into Red Teams now, we've got deny lists for sandboxes and sandbox detection. Not the typical sandbox detection for malware, but at a network level. So we're not even getting pingbacks from malware, which is great. It's kind of a bit of a win. So yeah, it was quite interesting. You could probably say that this is a bit of malware, but the intent wasn't to be malicious. It was to fuck with people in a good way. Yeah, sort of. But, I mean, you can fuck with people in a bad way, and you can fuck with people in a good way. And I'm going to go with this is in a good way. Your mileage may vary. This is really bad data because you're not going to be able to see it back, but this is more of the data that I got from Honey POC. Now, you'll see here that there's only 1,000 IPs because when I was doing this, I didn't fill in all of the data, primarily because the graph would have been over here because there was so much of it. But again, the US was at the top, China, Germany, Russia, there we go. And then the kind of cities broken down. So this chart here is from a company called IPinfo.io. They have free graphing available. You can drop in, I think it's a maximum of 1 million IPs. They'll allow you to give you geographical IP information, ASN information, ranges, all that sort of fun stuff. The kind of interesting stuff that I found was like up here, the kind of ASNs. When I did the BSides London talk, I was like, I don't really know, I mean, obviously Google and Amazon, China, but I didn't really know what this one was. And someone came up to me afterwards and went, that's Mulvad VPN. And I was like, that makes a lot more sense. And I started looking it up, and a lot of the traffic that I was seeing in the data set was from VPN providers, which kind of makes sense, because when you're going to run malware, of course you want to run it from a VPN, don't run it from home IP. Some people did, but that's then. No, it was also quite interesting. So, like, the kind of host names, when I was grabbing them, if it was coming from a Linux system that was not Ubuntu or Debian based, the host name would come back as null. So, like Red Hat, CentOS. Couldn't work out why. Still haven't worked out to this day, but I will do analysis at some point and work out. Other interesting IPs that aren't up here, there was a lot of, I want to say front companies that I found. So, in my BSides London talk, I talked about identifying companies that were threat actor fronts. And I looked into this a bit more and spoke to a lot of friends that are really good at Excel, also known as CTI specialists, cyber threat intelligence specialists, or Excel wizards, as I like to call them. I spoke to those guys about it. I was like, these are really interesting IPs, these are really interesting host names, like what's going on? They went, well, that's China, that's Israel. I was like, all right, that's pretty cool. And then one of the guys like dialed down the data. He was like, yeah, that's a front for this specific threat group. And I was like, okay, yeah, I'm not going to touch that anymore. I'll just leave it. He's like, yeah, you've got like 100 hits from that. Probably don't want to touch that because that looks sketchy as fuck. And I was like, okay, yeah, cool. Not gonna do that. So, talking about insider threats, the kind of insiders were quite interested. So, when I was talking about the source code earlier on, the environmental variables that I was grabbing, I got quite a lot of information that I didn't think I wanted. Well, yeah, probably shouldn't want. So I got quite a lot of Git tokens. So people that store their kind of private keys for GitHub to upload stuff to repositories for internal, corporate, and like external. I got a lot of credential leads. So surprisingly on Windows, a lot of people store like domain credentials in the PowerShell environmental variables, and my binary would pull them in and send them to me, which was interesting. People have some interesting password choices. And also what I worked out from there was corporate password policies, because the bigger the base 32 data, obviously the more data there's going to be in there. And there was one that came in with a gigabyte of traffic. It was like segmented. I was like, what the hell is this? Somebody's environmental variables had their entire like corporate pipeline of like uploads, full like don't know what the word for it is, but basically their full pipeline of upload and stuff was in their environmental variables. Don't know why. Contacted the company. I was like, lads, you might want to kind of not do this, or maybe check why this was run, and they never got back to me. So I was like, okay, well that's your problem. I'm not going to name you because I'm not a dick, but well, I'm a dick, but I'm not going to name you. A lot of internal domain names, kind of standard. That was in the hostname parameter. Internal username format, internal tooling. Now this was quite interesting because I was profiling sandboxes. I was working out what things were landing into. I was finding quite a lot of information regarding like how people were scanning things. So like random user agents, random IPs, random like host names, random formats in the environmental variables, and everything in between. And then kind of mental interesting stuff. So we'll talk a bit later on about like scanning and stuff, but I spoke to one of my colleagues who specialises in like industrial control systems, and I was like, what are these things? I was getting like random like strings of binary back. He's like, oh, they're from like PLCs. And I was like, what are people doing running binaries from GitHub on PLCs? He's like, I don't know. Go and look into it. And I looked into it, and it was people. So there was a vulnerability that came out in Siemens like PLCs. I don't know what PLCs is. ICS stuff. Essentially, there was a vulnerability that came out in the controllers, and it affected Windows. So as a result, the Windows binary was on GitHub, and almost all of the filtration plants round about the Middle East just downloaded this binary and ran it. And they must have like a group that were like, oh, go and run this thing, it's fine. And I found out a lot about how those things work. It was incredibly interesting and questionable as to the legalities of it. But I wasn't out to kind of gather information. I was just out to troll people, and the kind of accidental research project fell for that bit. I was talking a lot about like profiling virus tools. So these are kind of collection of virus tool host names that I found. Generally speaking, if you are in red or blue for that matter, and you see these host names, probably going to be virus tool. Almost always the kind of first hit I get would be like either win and then like a random string, or like John PC, Ali PC, Walker PC. And that was a kind of indication that, well, it's been uploaded to VirusTotal. But even more interesting, so when you upload something to VirusTotal, it runs once and does like a bunch of checks. then it'll run a couple of days later, then it'll run a month later, and then it'll run a couple, but it hasn't done a host name each time, but it's the same IP address, it's the same user agent, a bunch of other same things. So I started to profile that a bit more, and I worked out how VirusTotal do things. So they basically spin up like a Windows 7 or Windows 10 VM, they run it, they sleep it for like a month or something, and they wake it back up again and run the malware again. If you upload it to VirusTotal Enterprise, it does some other stuff, so it runs it on like a range of VMs, which I didn't know before, which is pretty interesting. I was chatting to someone who works in like detection engineering, and he was like, yeah, it does all this stuff, and it also spins up like clusters of other shit. So like, if you'd uploaded like a binary that could be run on Windows and like Linux, for example, so like a Go binary or whatever, you would get like ping match. So I tried it and it worked, but I didn't do it from a Honey POC perspective, just did it out of interest. So yeah, VirusTotal was pretty interesting. It's probably going to be a project that I'm going to do later on at some point. Like I built a tool off the back of this called Sandbox Spy, which I might release at some point, which is for profiling sandboxes, and it uses the techniques that I've learned from Honey POC to identify when it's in a sandbox and kind of tell you. So going back to what I was talking about earlier on, being in Red Team and kind of building detections for offensive tooling, what Sandbox Spy does is you send it in first and it works out if it's going to land in a sandbox, which is most useful in like mail gateways. So if you email like an ISO in, for example, or you email a link in, which is like HTML smuggling, if that hits a mail gateway, Sandbox Spy will go through the different steps and check what it's hitting. And once it hits a sandbox, it'll ping back immediately over DNS and be like, this is a sandbox, like bin it off, or these are the steps that I've got to. So if it's got far enough down the list that it's like, right, okay, you're allowed to get HT, like basically it does like exfil testing. If you can get DNS out, if you can get SMTP out, if you can get HTTP out, if you can get basically all the kind of main protocols you would try, it tries them. And if as soon as it gets a hit on them, it stores it. And then when it stops getting hits, it goes, right, okay, I've got them, and sends it off to me, which is quite an interesting project. I might present it at another conference. I might release it, I'm not sure. But the AutoPoC framework I probably will never release because it's like really dangerous on its own. Because basically anyone can plug their own stuff into it and just release POCs. So I've got the framework kicking about. Happy to show people, but I don't want to release it because, disinformation. It's not a fun place to be. So Log4j. Log4j was accidental Canaries. What happened was, when Log4j came out, my colleagues and I were working on proofs of concept to get things working. Like, okay, we want to prove that Log4j is affected by command execution or something else, like blind command execution. So I generated a bunch of proofs of concept URLs of, if you execute this JNDI, / whatever, and then the URL, it will send you a ping back over DNS or HTTP or whatever else. And that was designed purely to work out if things were vulnerable. And because I was doing blind command execution, I was basically chaining commands together. So it started off with hostname, and I was like, okay, I'm getting some hits back from that. Then put in environmental variables. And I just started putting actual command execution in, so like dollar open bracket and like a one-liner command. Obviously, base64, so when it was running, it was going to base D base64 and run it. And this was purely for my own detection and kind of identification of things. A lot of the kind of defensive guys on Twitter have me blocked because of Honey POC, but one of them picked it up and retweeted. They went, this is a really good idea. But in block capitals, he went, please change the URL because it's malicious, which is fair enough. It is. People didn't listen. They still ran it. And I got about maybe 4,000 or 5,000 hits from Log4j alone of legitimate insider host names and things. That wasn't meant to be malicious. Not malicious, sorry. That wasn't meant to be a troll. That was me trying to help the community, but people don't trust me anymore for some reason. So talked about water filtration. The kind of most common insider interesting things. So SCADA, or industrial control systems. I found a lot of water filtration plants, and a lot of them were in Israel, which was a bit scary because some of the pingbacks were from questionable sources and questionable IP ranges of certain intelligence services. And all of the vulnerabilities that affected SCADA, they happen to be either water filtration or some of them were manufacturing lines. So on a manufacturing line, they'll have the industrial control system, and then they'll have a Windows PC, like here, for example. And this will be used to interface with the production line. And what I found was on the connected machine, the data that I was getting, or the telemetry I was getting back, was kind of very relevant to what it was in. So if it was not connected to a corporate network, it would have some sort of bridge somewhere that would have an environmental variable to say, I'm actually part of abertay.local or whatever. I get a ping back. I'm like, that's a bit strange. Windows, I got almost all the endpoints run were Windows. The kind of more interesting ones were, I got 15,000 Windows 2000 boxes pinged back to me, and I'm like, I can't be right. 2021, 2022, 20 years later, but then you go into client environments, you go, actually, no, people, sometimes this is right. I was in an environment a couple of months ago where the client had 58,000 Windows 2003 machines still on the network. I was like, yeah, fuck's sake. It happens. A lot of web-facing apps. So the later PLCs that I generated, I started getting a bit more cheeky with the way in which I was developing things. So getting a bit more away from trolling and more into kind of telemetry. So I built a Go binary that would then take screenshots when it was running. So it would execute, pull all the information from the host name, the username, the environmental variable, and then if it was in a kind of GUI environment, it would take a screenshot. And it would then base64 the screenshot and then base stick to it and then hex it and then send it out. So as a result, you're getting massive packets sent out of network. In a blue team, you'd be like, oh, that's a bit strange that this random binary sending out a gig of data, but it still got out. And as a result, I got a lot of interesting internal web applications that you would never really see. So I found some kind of, a lot of PLCs, so scanning stuff, a lot of really strange intercom systems that people had, and a lot of branded things as well. So that's how I found a lot of incident threats initially, because it was being run against applications that were my company logo, and then whatever the application is. So I would contact the company and I'd be like, well, I found this is the story. It's like, well, I found this thing on your network and I can't really explain why I've got the details, but someone's been running random shit on your network and you probably should look into this. And I got on a phone with an airline with their blue team and I was like, right, this is the state of play, lads. Someone's downloaded the binary from GitHub that I've created. It's not malicious, but it sounds malicious. They've pointed it at your internal infrastructure, and it's not me, but it's them. And I've got all the data, but it's not my fault, it's their fault. And they were like, right, cool. What's the problem? I was like, well, if it'd been malicious, you'd be fucked. And they were like, yeah, okay, that's cool. We've got a bug bounty program, do you want to submit to it? And I was like, I mean, it's not a vulnerability. Human stupidity isn't really a bug class in HackerOne. The guy was like, well, it's technically remote code execution. I was like, well, I mean, it is, but I didn't achieve it. Just somebody ran a binary that I gave them. If that's classified as RCE, I'm fishing everyone with binaries. I mean, it's great. VPN. So, when Pulse Secure vulnerabilities came out, I released quite a lot of POCs, but what I found as well, so linked into the kind of screenshot, I found a lot of internal VPN portals, and so many companies, instead of just rolling with Cisco AnyConnect and just put it on the login, they try and roll their own and they write it in PHP or Perl, and I'm like, guys, don't break something that's already fixed. It works. And yeah, random host names as well. So kind of mapping back to Intel agencies. So this is there was maybe about 10 or 15 government Intel agencies. A lot of private security companies ran these things. I assume for threat intelligence to test that it's legitimate or not. But having sat in threat intelligence groups a lot of people. Sorry to everyone in the room before I say this, but threat intelligence people mostly are not fucking technical at all, don't understand how computers work. They're just Excel, yep, cool, no problem. Otherwise, not a clue. They're pretty good at Intel, don't get me wrong, but the kind of ones that are claimed to be cyber threat intelligence don't have a fucking Scooby. I said I wasn't going to swear. But hey, it's all good. So breakdown by execution. Mostly Windows. When I talked on my London talk, this was down as unknown initially, it's the 12% here. What I managed to reclassify it as was mostly sandbox traffic and mostly running inside of virtual machines that didn't have variables or anything set. So people would set up virtual machines with random usernames and random host names, but not unset the environmental variable, which didn't know you could do in Windows. You could just do unset and then percentage and then the variable and then percentage again. And it unsets it, so as a result, it just sends back a blank string, which was pretty cool. I was talking earlier on about the kind of example of what I was getting in terms of Slack pings. So this is an example on the left, of the kind of log4j ping back. So you probably can't see the back, but the memos that kind of note of what the thing is. Source IP I've plugged out because of obvious reasons. The flop is on the Canary side. You can put your canaries into flops, so different pools of canaries. Background context. So if it was previous ping back. Shit, forgot to censor the IP. It's fine. So yeah, quite one is destination port is quite interesting. So that tells me if it's a DNS ping back, it's a DNS ping back or HTTP or SMTP. And then the actual hostname, I've censored out that type. So the hostname there is, that's my URL that I've got on GitHub, plus the environmental variable of code execution, and then the timestamp in UTC for mapping out. And then on the right here, we've got the original Honey POC, and I forgot to censor that again. Good job, Andy. Really good job at this. So memo again, source IP, except, so what the difference between these two is, this is a DNS beacon or pingback, and this is an HTTP pingback. The main difference here is DNS is kind of limited on the data that you can put in a DNS packet, whereas HTTP, you can send back, with Canaries, you can send back any amount of HTTP headers. So what I did in my proofs of concept is I created a lot of custom HTTP headers with a lot of information in them. So for example, like accept is just standard, background context is just standard, hostname, pingback. The user agent I changed to be code execution. So the user agent for this specific one was server 03, which is the host name of the machine it was running on. I couldn't get some of the screenshots of things because they were like too big for the slide, but there was one that came back where the header was like X environmental variable, and this was the one that was getting traffic. It was like 18,000 Slack messages that came through one go because they're like little blocks of data. And I was like, that's a lot of Slack. But phone started pinging. I was like, oh, maybe it's the group chat going off. And I was like, no, there's a lot more in the group chat. And it was just like all Slack messages. And I've never logged into Slack and just seen 100+ messages like unread. I'm like, someone's been adding me a lot. But it was the bot kicking off. So it was pretty interesting. In terms of like data and stuff, so the kind of insiders I identified, these are unique companies and unique instances. I found about 100. I tried to contact all of them. About 10 of them got back to me. 2 of them allowed me to report to the bug bounty. 3 of them threatened legal action. Although it wasn't my fault, it was someone else doing it. There's about 280 corporate IP addresses I identified, so things that were like non-AWS, non-Azure, non-GCP, non-cloud providers, so like Abertay's IP range or whatever. I picked it from the site, sorry. The project timeline was 6 months long, so I ran from April to October, and yeah, it was good fun. And I've also rattled through this talk, so there's a few people I want to thank. So they're not in the room today, some of them aren't on, but I want to thank, first of all, Stix. Stix is a good pal of mine. That's his handle, he doesn't like going by his real name. He kind of took my original really shoddy Python code and helped me automate it and template it and make it a lot more structurally sound. So initially when I created AutoPoC, it was like a 1,000 line Python script, and Stix went, no, fuck that, you're making it modular, we're going to take everything out, we're going to put it into like folders and things. So as a result, it's like loads of different like modules that I could change and move about. So like the CVE polling was one, the environmental variables was another one, and lots of other bits and pieces. Aidan, who's also not here, but he's a fellow Scotsman, he taught me a lot about templating. So up until when I started creating this, I didn't really know about how to create templates in Go and how to create templates in Python and how to kind of, you create templates, of course, but you put like a string and you can autofill that with Python, which is really useful because like what was autofilling was like a unique Canary URL each time, a unique CVE ID each time, and just like unique information, which was a lot more interesting. And thanks Canary, so these guys are really helpful. So they've got a free service, which is canarytokens.org. None of this is sponsored by anyone, but like they gave me a lot of help. Their free service was really useful to start, but I found that because I wanted to automate it more, their free service is only available via the web interface, so I'd automated it, and I was like, actually, you guys got like an API? You went, well, we've got an open source one. It's kind of old because we've got a paid service. I was like, how much is your paid service? They went, we don't really sell it to individuals. I was like, okay, can I maybe get access for like 3 months or whatever, because I'm doing this project? I went, oh, you're the Rickroll guy. Yeah, cool. Have a go. I was like, all right, cool. So they gave me access to their API, and as a result, I was able to generate like lots of URLs autonomously, like just send like a curl request with the token and a bunch of other things. Really recommend them. Kevin Beaumont, he's the reason that AutoPoC kind of exists, because he replied to a tweet that I put out about like the exchange vulnerabilities. He was like, oh, why don't you automate it? And I think it's Florian, whatever his name is, he's blocked me on Twitter, but he replied like, don't do that, people's jobs are already hard enough. And then I told him to fuck off and he blocked me. So, yeah. IP Info, they give me access to their dashboards and stuff before they'd actually published them to public. So I was using their information to like look up where IPs and things were based initially. And I contacted them. I was like, "Have you guys got anything that I can do like en masse?" Because I've written like a geo map and I've managed to map it out. And their marketing was like, "Oh yeah, we'll get back to you." And one of their technical guys messaged me on LinkedIn anyway. Actually, I know you from somewhere. I was like, "Oh, that's never a good sign." We've got this product that's not out yet. It's out now, but it wasn't out in November. That's for mapping out IP addresses from a geographical perspective, and also from like where the ASNs and where the IP ranges and things are based. Why don't you give it a go? I was like, all right, cool. What's the limit on it? They went 1 million IPs. I went, right, I've got like 100 billion IPs. I went, we'll just run it 100 times. I went, okay. Yeah. So yeah, I got access to that. That was good fun. And I finally want to thank the gang. So Dave, Morgan, Alex, and Jess. They kind of like prevented me from getting like put in the back of a van by foreign intelligence services. Not because they were saving me from the van, but they were just like, maybe don't do this, or maybe don't mention that. And as a result, I'm still here. So it's all good for now. That somebody did try to get into the talk midway through, so it might have been the intelligence service, I'm not sure. If you want to read more about the information, this blog post here is the kind of all the data that I've kind of collated back in November. I'll tweet it out as well again. The tag has got the original post, so when I first put out the first POC back in July of 2020, I put out a blog post the next day of how I trolled the internet in one day and annoyed everyone. So it's quite... I've been told it's quite an interesting post. I've read it multiple times, I've proofread it things, and people seem to be enjoying it. And if you want to follow me on Twitter, if you don't already, name's Zephyrfish. Thanks for listening. Has anyone got any questions? Yes.
So, like reversing this, like looking at it from a risk perspective, what advice would you have to like CTI teams in like investing threat intel feeds so that they don't fall victim to something like this?
In terms of vet, so the question is how do you look at it from a risk perspective and how to vet the kind of intelligence? What I would say is, from a threat intelligence perspective, kind of verifying that things are legitimate. So if somebody releases a proof of concept and it's a raw binary on like a website, probably don't trust it unless the source is available. Obviously, rapid and threat intel, like things get released all the time, but being quite vigilant about what's being released is kind of important. So from a threat intelligence company perspective, looking at how you're hiring, so going right back to hiring and maybe look at people that have got actual hands-on technical experience. When people say they're technical, often they might not have the correct like technical understanding that they need. So maybe looking at who you're hiring and what you're hiring them for. If you're hiring to just like troll feeds, if they can't troll feeds, if they can't verify what they're taking in, they've got no chance of what's going out. So yeah, take it right back, look at who you're hiring, and also kind of be a bit more vigilant with what's being run. And also don't run it on your host machine, run it inside a virtual machine. Don't give a network access, the kind of usual operational security kind of stuff. So,
have you like seen a guide or anything like around that exists with like advice on technically what to vet when you're looking at a source or a binary, or is that something that you would believe?
There are like reverse engineering guides and stuff for binaries as to like safe ways of doing it, but I don't know if there's like a general guide for like threat intelligence as a whole, because it's kind of, it really varies. So yeah. Any other questions? Yep.
So you mentioned you're not going to release the framework, but with the CD polling, quite difficult times. For example, CISA, when they release CD, sometimes they just say the product. And it's really, I can imagine that's quite a hard thing to manage. How do you get that sorted? Skip them.
No, like the way that I automated is it was pulled in descriptions from MITRE, and there's another like I think it's like a Dutch university that they pull it in from the various sites and they put it in one place. In terms of the ones that are very vague, it's like it affects like I don't know, like HP monitors or something. I would still pull it in and just drop it in. People still run it, so people are fucking idiots basically. Yeah. Any other questions, concerns? Yep.
What heuristic did you use? You had a slide where you had the different demographics, threat intelligence, securities, insider threat, other. You talked about the sandbox now.
Yep.
Kind of disambiguate the other threat intel, probably using that sort of curious with the
So
script kiddies versus insider threat.
Let me go back to the slide. This one.
Yes.
So script kiddies were kind of worked out based on kind of home IPs and stuff, and like how they were being run. Insider threat was based upon the information that I was identifying. So those kind of merged into one at times, but like script kiddies would take the CVE and run it against an IP, and then another IP, and another IP, and another IP, and another IP, loads of different IPs, and they'd be like different companies and all sorts of. Whereas insider threat was targeting mostly internal IPs and some like corporate ranges, and not just like, for example, 10, 10, 21, 2, 3, 4, or like a /24, quite a bit suspicious. So, and also like the host names I was getting back. Most of the time, the people that run it instead of VM, it'll be like desktop dash and like a string. The ones that were like internal companies were actually like computer names, so like Abertay 1 or Workstation 1 kind of thing. So that's how I differentiate between them. Anyone else? Yep.
You said at one point that some companies threatened you to take legal action against people developing that, even though you were not using it.
Yep.
Is it illegal to develop something that can be harmed, even though you don't use it? Isn't that against the...
No, the Computer Misuse Act is about intent, but they are currently reforming the Computer Misuse Act. So it's like Section 1, 2, and 3A are about the intent. The intent of creating this wasn't to like get malicious execution. It was just to kind of get an understanding of what was being done and what was being run. It would be a different story if I was uploading like Cobalt Strike beacons or like a wiper, for example, that just like wipes your machine. That would be kind of veering into the kind of illegal aspect of stuff. When I was at BSides London, I actually spoke to the director of NCSC, and I was like, "Yo, is this illegal?" And he was like, "Bit of a grey area, but as long as you're not like hurting anyone, it should be fine." I was like, "So if I'm not running and punching people, it's no bother?" He was like, "Yeah, pretty much." I was like, "All right, cool." So don't do crime, kids. It's bad. Don't punch people. It's also bad. Anyone else? No. Well, 15 minutes. Get an early lunch. Cheers.